In this video, we'll discuss the derivation of the product rule algebraically. In the last video, we introduced the product rule and we showed 3 examples with graphs on Desmos.com. Here, we're just going to come up with that product rule in the first place. It's just a lot of adding and subtracting the right things to make the rule, or to make the derivative results sort of come out of the right-hand side of the equation. But let's look at the product rule again so that we see sort of what we're doing. I've got the derivative of a product is the derivative of the first function times the second function, undifferentiated, plus the derivative of the second function times the first. And remember that the derivative of a function in general is the limit as delta x approaches 0 of f at x plus delta x minus f of x. That's just a change in y on that graph divided by delta x. So when we are trying to derive the derivative of a product, we're going to apply this rule and try to make it look like this. Try to make the expression that we get for this limit to look like these two, or the sum of these two terms. So we've got the limit as delta x approaches 0 of our function evaluated at x plus delta x. So we take f and we replace x with x plus delta x, and we multiply by g evaluated at x plus delta x. Then we subtract the original function, which is f of x times g of x, and we're dividing by delta x. So we look at this and we compare it to this and we compare it to this. We know that we're supposed to have an f of x plus delta x minus f of x divided by delta x. And I notice that right here, I've got an x plus delta x, or f of x plus delta x divided by delta x. So that's just that first term in that, it's not a rational function, but in that quotient, I've got that divided by that and that divided by that. So really what I need is to be able to subtract f of x from that. And then I'll be able to sort of get what I want. I'll have this times g of x. But the problem is if I just had an f here, just subtracting f times g, it wouldn't work because I've got this extra function. So I say, well, what do? We're just going to add and subtract just the right thing so that we'll have this as a factor. And I know that I'm going to do that because I see this f of x plus delta x divided by f of x here, or divided by delta x here. But I want to be able to factor out this g of x plus delta x. So we'll write down our first expression in the numerator. And I'm saying I really want a negative f of x times the same thing so that I can factor out that g of x plus delta x from this expression right here. So now if I factor out that g of x plus delta x, I'll have g of x plus delta x times this. And that looks a lot like this first term, the derivative of f times g. Now I can't just do that. If I subtract this term from the numerator, I have to also add it. Otherwise, I'm changing the value of my function, and I don't want to change the value of the function. So I've got that there. And now I'm going to regroup. Group these two together and group these two together. And then we've got this divided by this plus this divided by that. And then hopefully with a little bit of factoring, we'll be able to see that this is something equal to that. So we'll say this first expression is g of x plus delta x. So that's what these two have in common. Times f of x plus delta x minus f of x, all divided by delta x. And that looks like that. So I know that I'm probably on the right track. And then over here, I'm looking for something that these two terms have in common. And of course, if you've got a fraction, a plus b divided by c, that's the same as a over c plus b over c. Because if I have a common denominator, I just add the numerators. So we're just doing that in reverse. I'm just saying this divided, or this plus this divided by delta x is this expression divided by delta x, which simplifies to this, plus this expression divided by delta x. But again, I'm going to look at these two expressions and say, what do they have in common? They've got an f of x in common. So I'll factor that out. And then what's left is g of x plus delta x minus g of x, and we're dividing by delta x. And that looks like that expression evaluated at g rather than f. So now we'll take the limit as delta x approaches 0. Now remember, we've got a few limit laws. The limit of a product as x approaches x naught is the product of the limits. So provided that the limit of f exists as x approaches x naught and the limit of g exists as x approaches x naught, you can just apply that limit to both of those, provided those two exist, and we get the right answer. And then the limit of a sum is the sum of the limits. So if I'm adding two functions, I just take the limit of the first function, and then I add the limit of the second function. Now, I know it can be a little tricky, because you might be thinking, I've got all these derivative rules and then these limit rules, and how are they different from each other? Just know that the derivative rules are giving you a formula for the slope, and the limit rules, well, they're just telling you, well, what the function values approach as x approaches a particular value. And that's what we need right here. Okay, so I'm keeping that in mind and using both of these to evaluate this limit. I've got the limit as delta x approaches 0 of this. This expression is just going to approach g of x because delta x goes to 0, and I have g of x in that case. G of x plus 0 is going to be g of x. So that's going to go to 0. Then if I take the limit as delta x approaches 0 of this, I get f prime. And then the limit as delta x approaches 0 of this is just the function itself, because the limit of a constant is the constant. And if you're saying, how does that work again? I thought the limit was 0. I say, no, the derivative of a constant is 0 because the slope of a constant function is 0. But if I'm looking at, let's say, like y equals 3, of course, as I approach x naught, the y values stay 3. The limiting values are 3. But if I'm looking for the slope of that function, the slope is 0. So you want to be careful. The limit of a constant is 0, but the derivative, or the limit of a constant is the constant, but the derivative of a constant is 0. It's getting sort of into the weeds now. But basically, you just take the limit of this as delta x approaches 0, multiply by the limit of this as delta x approaches 0, add the limit of this as delta x approaches 0, multiply by the limit of this as delta x approaches 0, so you end up with this. Now, you really don't have to show this step. Typically, I would just substitute at this point, delta x equals 0. But just to emphasize what we're doing, the limit of the sum is the sum of the limits. I've got the limit of this guy plus the limit of this guy. And then when I take the limit of this, it's the limit of the product is the product of the limit. So I have the limit of this times the limit of that. All right. And this function is continuous delta x equals 0. So we get g of x there. And this is the definition of the derivative of f. And then here, this is constant with regard to this delta x. It doesn't have a delta x in it. So we're going to apply this limit law. the limit of a function that is constant with respect to this variable, delta x, is just that function. And then this is the definition of the derivative of g of x. So I said that the derivative of a product is the derivative of the first times the second plus the derivative of the second times the first. So this is the derivative of the first times the second plus the derivative of the second times the first. The order is a little different, but multiplication is commutative, so we know that that's okay. So that's the idea. It's actually relatively simple. But the way we did it, the way we think through this derivation is we look at this expression, we say, how can I make this look like this? And you say, I can make this look like this if I can rewrite it so that I have quantities that have this basic form. This is the form of the derivative of f, and if I have replaced the f's with g's, this is also the form of the derivative of g. And we said all we had to do was notice that we had this f of x plus delta x divided by delta x here, and say, oh, it's multiplied by this extra g plus g of x plus delta x. How can I get rid of that? Well, I subtract the thing that I want times that g, so that those have that common factor, and then I also add the thing that I want plus, or I add the thing that I want times the g, so that I'm not actually changing that numerator at all. And then we factor this piece, and evaluate the limits using the limit laws. That's it. Let me know if you have any questions.